A spiral spring of natural length 20 centimeters has a scale pan hanging on its lower end, while the other end is fixed firmly to a support. When an object of mass 50 grams is placed in the pan, the length of the spring becomes 22 centimeters. When another object of mass 70 grams is placed in the pan, the length becomes 22.25 centimeters. Calculate the mass of the scale pan given the gravity as 10 meter per second squared. Let's understand this question first. We have a spring here which was originally 20 centimeters. Then there is a scale pan. This is our scale pan hanging on it. If a mass of 50 grams is loaded in this pan, the length of our spring extended to 22 centimeters. Then another load of 70 grams was loaded in the same pan and the length was 22.25 centimeters. So the question is, what is the mass of the pan in which the loads were loaded? Now to begin with, let's understand what is going on here. Let's look at the weight of the pan plus the masses. Now we know that weight of the body is the mass multiplied by gravity acting on the body. But in this case, we have two objects. We have the pan and then we have the 50-gram mass. So let's assume the mass of the first one, 50 gram was M1, and then that of the 70 is M2. The scale pan also has its own mass. Let's call that M. This means that the weight here, the total weight of the mass of the pan plus that of the loaded object is going to be the sum of the masses times gravity. So this means that the weight is going to be the sum of the mass for the first one. The sum of the masses is going to be M1 plus M multiplied by gravity. And the weight here is going to be the sum of the masses, which is M2 plus M, which is the mass of the scale pan multiplied by gravity. We know that our M1 is 50 grams and our gravity is 10 meter per second, and our M2 is 70 grams and our G gravity is 10 meter per second. So at the appropriate time, we will do the necessary substitution. But for now, let's look at this. We all know that Hooke's law, provided the elastic limit is not exceeded, the force acting on this body is proportional to the extension or the change in length in the spring, where K is our spring constant. But what is the force acting here? The force is the same as the weight acting downwards on the springs. So you can say that the force is equal to weight, which is equal to mass times gravity. But then we've just established that the mass in this case is not only one mass, but we are talking about two masses in each case. We have the mass of the object and the mass of the scale pan. That is why we have this and that. So we are going to use this relation to continue our calculation. Now we've all agreed that the force acting on the spring is equal to Ke, which is the extension in the spring, and we've agreed that the force is the same as the weight of the object, and the weight is as a result of the mass of the load plus the mass of the pan multiplied by gravity, and this is equal to our Ke. This is the same as what is happening here. F equals to Ke, and then our F is the weight, which is M2, which is the mass of the load, plus M, which is the mass of the pan, all multiplied by gravity, equals to Ke. Now, what is the extension or the change in length? The change in length is the distance from here to there. Means that this was the original length, and then it increased to 22 centimeters. So to get this one, we subtract 20 from 22, which gives us 2 centimeters. So our E, or our change in length, is 2 centimeters, subtracting 20 from 22 centimeters. Likewise, if you come here, this was our original length 20, and this was the length after the load was added to the pan, then the extension will be what we have here. The extension will be from here to here, which is 22.25 centimeters minus 20, and that will give us 2.25 centimeters. So we have our extension for both. Extension here equals to 2.25 centimeters, and the extension here is equal to 2 centimeters. So we can substitute that into our work. We know that our M1 is 50 grams plus M, which we don't know, we are yet to look for it, multiplied by 10, which is gravity. Then we have K, which is not specified here, multiplied by 2, which is extension for the 50 grams. Now we come here, we have 70, which is the mass of the second loaded object, plus m, which is the mass of the pan, multiplied by 10, which is gravity. Then we have k multiplied by 2.25 centimeters. So we are going to expand. At this point, it's just algebra. We are going to expand. Here, if I open this bracket, I get 500 plus 10m equals to 2k. And here I get 700 plus 10m equals to 2.25 k. So this gives me two equations which I have to solve simultaneously. I can decide to simplify or just proceed with my calculation. So let me call this equation 1 and call this equation 2. So since I'm looking for m, I'm not required to look for k. So let me make k the subject in one of them and substitute in the other, so that k will go away and I'll solve for my m straightforward. So let's take equation 1. From equation 1, let me make k the subject. So making k the subject in equation 1, I get k to be equal to 500 plus 10m all divided by 2. So making k the subject here, so having k to be equal to all these, I can substitute this in place of k in my equation 2. So I'm substituting in equation 2. So this gives me 700 plus 10m equals to 2.25. K is now 500 plus 10m divided by 2. So we expand. So this, I get 700 plus 10m equals to 2.25 multiplied by 500 gives me 1125. So I get 1125 plus 2.25 times 10 gives me 22.5 m, all divided by 2. I'm going to multiply through by 2 so I can get rid of the fraction. So this gives me 700 times 2 gives me 1400 plus 20m equals to 1125 plus 2.5 m. So here I group like terms. I have this and that, and then this and that. I'm going to group like terms. So let me do it this way. 1400 minus 1125 equals to 22.5 m minus 20 m. This will give me 275 being equal to 2.5 m. Now I'm looking for m. All I need to do is to divide both sides by 2.5. So here by 2.5, here by 2.5. So this will cancel that, and my m is going to be equal to 110 grams or 110 grams.